In this video, we're going to be looking at some other types of functions where we can apply the power rule. In a previous video, we learned that the derivative of a function that I write in the form of x to the n is equal to n times x to the n minus 1 power. And all of the examples that we've seen so far have had exponents that are positive integers. Well, today we're going to extend that to different types of functions. Let's consider in this first example the function y is equal to 1 over x to the fourth. Now when I look at this, it certainly looks like a rational function. It is a rational function, but it is a function that I can rewrite. Whenever we have a variable with an exponent in the denominator, we can rewrite that exponent as a negative number. And so this expression 1 over x to the fourth can be rewritten as x to the negative 4. Now that we have it in that form, y is equal to x to the negative 4, we have it in the form of x to the n. Now I can apply my power rule. The derivative would be equal to n times x, so my exponent, my n value, that's going to come to the front, negative 4 times x, and then my new exponent is going to be n minus 1. But you have to be really careful here because n is a negative number. And if I do negative 4 minus 1, that's actually going to be equal to negative 4 times x to the negative 5. And then once we get this answer, if we need to plug in a value for x, maybe we're trying to find our answer among some multiple choice answers, we need to be able to rewrite it back into the other form. I can rewrite this as negative 4 over x to the fifth. Let's look at one more example like this one. Let's say that I have f of x equal to 3 over x squared plus 2 over x cubed. Okay, so in this function I've got two separate terms. They both only have variables in the denominator, and that's a clue that we can rewrite this as in the x to the n form. So on my first term, that x squared in the denominator, I'm going to rewrite that as x to the negative 2. This 3 that's in the numerator, it's just going to stay 3 times x to the negative 2 plus 2 times x to the negative 3. So now I have both of the terms in my expression in the form of x to the n. And that means I can use my power rule. Now notice my notation so far. I started off with f of x equals, still f of x equals what we have written here because I've just rewritten the function. I haven't taken a derivative yet. Now I'm ready to do that. F prime of x is equal to, and now we're going to apply the power rule. So for my first term, the negative 2 is going to come to the front, and we're going to multiply it by the 3 that's there. So negative 2 times 3 is negative 6x, and then remember I'm subtracting 1 from my exponent, but my exponent's already negative. Negative 2 minus 1 would be negative 3. And then we're going to do the same thing to the next term. My exponent of negative 3 is going to be multiplied by 2, and so I get minus 6, or plus negative 6 if you prefer, x. And then negative 3 minus 1 would be negative 4. And now I just want to rewrite this back without using negative exponents. So f prime of x would be equal to negative 6 over x to the third minus 6 over x to the fourth. Now another type of function where we can apply the power rule after rewriting the function is when we have square root functions. So let's look at this example. We'll just start with a simple y equals the square root of x. Whenever we have roots in our function, remember that we can rewrite those as fraction powers. I can rewrite this as x to the 1/2. So I have y equals x to the 1/2, and now we're ready to take our derivative. And x to the 1/2, that is in our x to the n format, so we can apply our power rule. The n, the exponent, comes to the front, 1/2 times x, and then my exponent 1/2 minus 1. So in this case, we get 1/2 x to the negative 1/2, because 1/2 minus 1 would be negative 1/2. Now this gets a little bit more complicated when we go to rewrite it, because now if you notice in my exponent, I have a fraction, which means I'm going to have a root in my rewrite, but I also have a negative. And so we're using both of those exponent rules here to rewrite this function. I'm going to have 1 over 2, that's from the 1/2 coefficient. Since my exponent is negative, I'm going to put the x in the denominator, and since the exponent is 1/2, I'm going to make it a square root. And so my derivative here would be 1 over 2 times the square root of x. Let's look at another example like this one. Let's consider this function. F of x is equal to 2 times the 5th root of x cubed. So I see that I have a root in my function. Roots can be rewritten as fraction powers. So f of x is going to be equal to, now this 2 that's out on the front, it's going to stay 2 times x. It's a 5th root, and so that 5 is going to go in the denominator, but that exponent of 3 that's on the x, it's going to go into the numerator. So the 5th root of x cubed is rewritten as x to the 3/5 power. Now I have it in the form of x to the n, and I'm ready to take a derivative. F prime of x would be equal to 2 times 3/5. That exponent is going to come to the front and multiply by the coefficient 2. And then I have x to the 3/5 minus 1 power. And if you can do that subtraction in your head, that's fine. You don't have to show this step. I'm just showing it here for clarification. So 2 times 3/5, that would be 6/5 x. And then 3/5 minus 1, that's like, let me just write out here on the side. 3/5 minus 1 is actually like 3/5 minus 5/5 if I get a common denominator. And that, of course, would be negative 2/5. So x to the, to the negative 2/5 power. Last step, I want to rewrite this back without the negative or fraction exponents. So my derivative would be equal to 6 over 5. I notice that my exponent is negative, and so that's going to put my x in the denominator. And then it's a fraction, so I've got a root. My denominator is 5, so it's going to be a 5th root of x squared. And that's my derivative. Let's look at one final example that, wow, sorry, I keep doing that. One final example that combines both of the rules. F of x is equal to 5 over the cube root of x squared. So because my only variable is in the denominator, that means I can just rewrite this in an x to the n form, and so that's what I want to do. F of x is equal to the 5 that's in the numerator, that's going to stay, times x, and since x was in the denominator, I'm rewriting this as a negative exponent, and then since it's a root, a cube root, my exponent's going to be a fraction with a denominator of 3, and my numerator is 2 because of the squared on the x. So now I have my function rewritten in the form of x to the n, And I'm ready to find a derivative. F prime is equal to 5 times negative 2/3 x, and then I want to do negative 2/3 minus 1. So I'm going to write that little fraction subtraction out to the side. Negative 2/3 minus 1 would actually be negative 2/3 minus 3/3 to get a common denominator, and that would be negative 5/3. So back over here to my derivative, f prime of x is equal to 5 times negative 2/3 would be negative 10/3 x to the negative 5/3. And then last step, let's rewrite this without negative or fraction exponents. So negative 10/3. Since my exponent is negative, I'm going to put x in the denominator. Since I have a fraction exponent, I'm going to make it a root. My denominator is 3, so that's a cube root. And then the exponent on the x would be the numerator 5. And that would be our final answer.